Hi.
Hi, Dr. Madhulika.
Hi,
Yes,
ma'am.
we.
I have joined from app now. It was not
Okay,
working for the browser one, so I have tried
okay,
from the desktop app. It's working.
okay.
Okay. So,
So, good
you
evening,
want me?
everyone. Yes, yes. Good evening, everyone. I, Dr. Seema Verma, welcome you all again to the second day of ATAL Online Faculty Development Program on recent trends in deep learning and large language models. Now, I welcome our speaker for today, Dr. Madhulika Bhatia. Dr. Madhulika Bhatia is working as Software Development Officer with the Digital Healthcare Wales, UK. She holds a diploma in computer science and engineering, BE in computer science and engineering, MBA in information technology, MTech in computer science, and PhD from MIT University, Noida. She has a total of 18 years of teaching experience. She published almost 58 research papers in national, international conferences and journals. She is also the author of two books. She filed two provisional patents. She attended and organized many workshops, guest lectures, seminars. She is also a member of many technical societies like IET, ACM, UACEE, IEEE. She reviewed for Elsewhere, Halion, IGI, IEEE, Access, and as well as did editorial for Springer Nature, Switzerland. She has guided 12 MTech theses and around 50 BTech major and minor projects, and guiding PhD scholars' research collaborations. She delivered expert talks and hands-on sessions in AICT-sponsored workshops in collaboration with IIT Roorkee. She was also invited for expert talk by NIFT Patna. She has international exposure on various projects and research collaboration with the University of Cape Town, South Africa, and Lancaster University, UK. She was also invited as visiting researcher by Cardiff Metropolitan University, UK. She is pursuing her postdoctoral from the Federal University of Ceará, Brazil. Welcome, Dr. Madhulika, and over to you now.
Thank you, ma'am, for such introduction, and I'm very overwhelmed and thankful to the organizers, Dr. KK Singh sir and Dr. Seema ma'am, and Delhi Technical Campus, Greater Noida, who has given me this platform to speak. Okay, not wasting much time. I would like to get the permission from the organizers that if I am able to start now.
Yes, yes.
Okay, I'm sharing my PPT, and I will ask for some acknowledgement when I will play some videos. So I will be starting with sharing my screen. Okay. Mm, I hope my screen is visible.
Yes.
Okay. Okay. Today I'm going to share my thoughts and few of the practical sessions that can be delivered with AI enabled features that are included in Tableau and BI. And this is all work around data visualization, that how data visualization can be enhanced and additionally can be expedite and making our work more automated with the help of AI enabled features that are included recently in Tableau and BI tools. So I will be starting with few terms on data visualization, then moving towards a few environment pics and the snippets I have taken from the Tableau desktop environment, giving a quick brief introduction about the Tableau so that you can come to know about what Tableau is, Tableau environment, dashboard and stories. And then I quickly move on the AI feature that are included in the Tableau, and then I will show you some of the screenshot and hands-on over BI tool, that how BI can help us in machine learning models and some of the AI enabled feature that can help our data to be automatically analyzed with few features that are being added in BI and Tableau with the generative AI features. So starting with my presentation, that why and how we will do with the data in context, how we can find out the patterns, how we can present our collected data in the form of raw facts and present the arguments in the form of stories. They all are good, colorful features that are enabled in the Tableau environment. So there are something that the visualization can have 65% of the information that is perceived from our eye, and only 1% is listened through ears. Here the visualization comes in the picture. So visualization is for recording, analyzing and communicating. For storing, we start with storing of data, we start with patterns, and then we convey the information. After that, we record the information, means we are gathering the raw data and observations. We are getting the sensor information about weather forecast, recording the temperature, humidity is the example of recording some of the data. And here come when we initially record the raw data and can be plotted as sample graphs and charts and line charts and temperature trends to detect some of the missing data during the collection. So here we record. This is the step one. Then after recording, we will analyze. We will have certain patterns, and then we will apply some machine learning algorithms to dig out the patterns from the data, and some rainfall patterns, that how much is the rainfall that has happened last year and can be predicted this year. So this kind of analysis we do with the help of ML algorithms, and then we use visualization in this step while we have done it with recording as well, and then we can insert our visualization in the analysis as well. So we can analyze the predictive trends for the rainfall, humidity, how much heat will be there, how much cold waves will be there. So we can have many emerging patterns out of data with the help of visualization. So after that, we will communicate. What we will do with recording and analyzing if we are not interested in communicating it with the stakeholders or the end user. So we will have our insight effectively with the stakeholders by generating an interactive dashboard to visualize weather forecasting to the farmers, to the decision makers, to the clients. If we will record, we will analyze, and we will visualize, and we will put that all part to our client and the stakeholder to have better business insight and to embed those visualization in their working pattern. So it will help to enable a very quick understanding of the data when we visualize something. Obviously, if we will I will give you a 2 or 3 page paper to read about the data, or I will give you a 5 embedded worksheet in an Excel workbook, it will consume your time and it will not give you any insight or decision making power to read the rows and columns in the numbers. Better, I will convert those Excel sheet into a visualization, trends, graphs, line graphs, and heat maps. It will give you a better understanding and you can have a quick decision over visualization. So it will act as a bridge between analysis, communication, and making the complex data interpretable, as well as it will give you an action insight that what you will action out of that data. So this is the beauty of data visualization. And some examples I have given, that how visualization can give you a clear picture, like a day in the life of Americans. Data visualization can capture the flow of data and analyze and illustrate the small amount of data that can be that is surveyed from the American time use survey from 2014. That data will actually have collected from the citizens of American, a day in the life of American, that how they spend their daytime, actually moving from different areas to the diagram based on the time of on the particular time of day. So each dot represent a person, each color represent the activity. So how these can be pictured, that micro data that can be collected from the people of any country, that how they spend their time. This I can show you that at 8:04 a.m. the wake up type, most of the people wake up in US at around 8:04. So 2% of people are busy in sports, and some less than 1% are busy in their religion, volunteering less than 1, phone calls less than 1, miscellaneous less than 1, sleeping 22% of the people are sleeping, personal care only 8%, and eating, drinking, education, housework, household care, non-household care, shopping. And this is a particular point of micro data that has been collected around 8 a.m. in the America. So this is how visualization can capture a small amount of detailing and visualize very easily and have a quick insight that what people are doing at particular point of time. So this is one example I want to give you to start the background for data visualization. The second example I am presenting, infectious disease, that the impact of vaccines, that I have taken from a data set of Wall Street Journal that illustrate how introduction of vaccine and medicine and injection, that prevalence and widespread the certain infection diseases among the people of the country, and visualization show the measurement over 70 some years and across all 50 states that can be captured with the help of a heat map that can show you measurement from 0 to highest impact 200. So the dark colors are showing the maximum impact and the lighter one are showing the less impact. So how the widespread of certain infectious disease will be moderated with the help of introduction of vaccines or medicines. So this is how we can use visualization. So the use of computer supported interactive visual representation of some abstract data collected from any recording method or analysis is information visualization. And then we will take that data to amplify our cognition of brain to actually see what data is showing. So these are some of the circles I have taken, and if they are scattered, we are not like we will spend some time to count that, and if we have any advanced perceptual abilities that we will add to these circles, this our brain will make aggregate some of these patterns very quickly because they are visual patterns. So the introduction of visualization in any business is very important to gather all the data quickly in the form of patterns. So there are three kinds of visualization: scientific, information, and visuals. So scientific visualization is that have a natural geometric structure, that any geometric structure I can see a dot, a point over a paper is also a geometric structure because it is a dot and a point. And information visualization deal with more abstract data represented by tree or graph. Visual analytics is the integration of visualization in sense of making and reasoning. So we have this visualization, scientific and information, like there are various aspects of scientific and information visualization, like these aspects are data nature. What is the nature of data? Is it physical, spatial, or continuous data? If it is information visualization, then the data nature aspect will be abstract, discrete, and categorical. Primary use of data is for what purpose? Like if it's for science and engineering, it can be categorized in the form of scientific visualization, and if it is for social sciences and any business or general related data, it is only information visualization. Then we have some examples like collecting the weather patterns and simulating them over a simulation tool, or you can have a financial stock trends, that which stock is going up and which is not performing up to the mark, is any information visualization. The complexity also have important aspects to categorize scientific and the information visualization, like often uses 3D and computational models to represent scientific geometrical patterns, and typically 2D or interactive displays are always captured with information visualization. Scientific visualization we have like climate modeling, like hurricanes, any earthquakes; medical imaging like analysis of any MRI or CT scans; simulating airflow over a aircraft wing, we can have a scientific visualization in these. So molecular structure, weather patterns, fluid dynamics, that helps researchers to analyze the scientific phenomena is coming under scientific visualization. I have taken one example of total number of hurricanes I have analyzed in Tableau, that plus 60% of the hurricane force, which is greater than equal to 4, and 6.5% hurricane force was less than equal to 3 in the era of 1900 to 1950. And then 1950 to 2000, the data shows total number of hurricanes, it's 24%, and then 12.5 was greater than equal to 4. So this is how 1 to 3 and 4 to 5, 4, 3, 3, these are analyzed in the form of this chart in Tableau, and years I have taken here on the horizontal axis. So this is how we can have a dashboard over this with the help of Tableau. Information visualization always represent the abstract and non-physical or categorical data, like we can use charts like bar charts, scatter plot, tree maps, and network graphs. We can create interactive dashboards out of that, and always we will have unstructured data like any paragraph, any text, any blog, Twitter post, anything we can take in the form of information visualization that is not very structured, and we are not knowing the source of that data, that where it is coming from. It can be a something written in the survey form in a paragraph, or it can be any blog, any tweet, any comment on the social media platform. So we categorize it as an information visualization. So we here for the information visualization we have dashboards and interactive dashboards and stories that can help us to represent them nicely. Then I have one video to show uh, that what it will summarize all the points that a Tableau can do for us. So I will pause it here and will share my screen again to have a sound. Ma'am, you have to confirm whether I'm audible with the video sound or not. Just playing it for you. One second. Um, I will show you. This I will show you on my Tableau desktop. Okay, sharing my screen again. We'll play that afterwards on my direct on my Tableau desktop. That how information visualization and social media analytics will shown on Tableau. Okay, continuing from my current slide. So data visualization, a very formal definition that has a visual graphs and people can understand graph, charts and graphics. So it is very important that how it can be used as a reporting tool for the data. Ma'am, I am audible. My screen is also visible.
Yes, yes.
Okay, thank you. So facts will not surprise us that visual data is very easy to remember than words. So it is very important that we must we have 90% of the information that is transmitted to the brain is visual and human process image 60,000 times more fast than anyone else. So information is very difficult to remember than the charts that are visually represented. So we are living in the age of big data where the lot of data is just being saved in the repository and the data sources and the databases. So we need like the facts are droning into the big data that we are collecting it from various sources and where the facts will be shown. They're droning inside and just piled up in the data while we can see that the patient data in the hospital management system or whether it is in the banking sector. There are a lot of information that had piled up and the big data size is increasing day by day. So we have information designers that used to talk over TED Talks and many things that the visualizing information turned into a very huge landscape that we can't able to explore from the reading the data readings and values. So we need an information map that can be converted into a visualization map so that the lost information can be regained and insight can be taken back from the data. So this is how people are talking over the platforms about capturing the data into visualization. So we have five additional benefits of visualization like message amplification that can give you a sense of credibility to our content. Then we have some meaningless data that the message meaning will be entirely lost. Sometimes we can't gain something out of data. So this is the second benefit that visualization can take up to convert our meaningless data into a meaningful insight. Some visual insights also an additional benefit provided by the visualization, like we have a meaningful data, like I have captured something a sales revenue from 2011 and 18. If I will convert this revenue from Excel sheet to the bar this graph, so this is how data visualization can be pictured well, that I can see that in 2011 it is 69.9 revenue generated and in 2018 it was 110. So this is how easily I can capture from my eyes that 2018 is the maximum one and 2011 the revenue generated was the least one. So this is how I can differentiate between data that has less meaning, less insight, and when we convert it into visualization it has different picture. This is time saving as well. The facts and figures and the meanings that are figuring out engage the audience in a blink of eye. They process visual information more faster. Then scenario monitoring stock market trends. The context is that stock analysts need a more monitor price fluctuations, trade volumes across the multiple stock in real time. So without visualization, analysts would have to manually sit and switch from one spreadsheet to another to raw to analyze and process the numerical data related to the stock. It is very time consuming and obviously an error prone process. So a solution is data visualization. We can have a real-time dashboards, we can have line charts, we can have heat maps, candlestick charts that can process complex data sets instantly. And now AI feature is also there, so it will help you for decision making. We can collect the data, we can correct, and we can share it through multiple platforms. We will have a mobile view, we can have a tablet view of the dashboards, we can share anywhere at any platform with our team. Fact is that we have virtually an unlimited freedom how we are representing the data. It is very difficult question is how best to represent it. So this is an effective data visualization can be as a communication tool if it is done correctly. So I always show this video. I have shown it in my one previous where I was invited 2 days back. So I have shown this as well. So I want to play this video again. If you can see. Mm. Ma'am, you have to confirm that it is with sound.
Not yet.
Okay, I'm playing it. Sharing it with sound. It's with sound, ma'am.
Yes.
Okay.
Visualization is right at the heart of my own work too. I teach global health. And I know having the data is not enough. I have to show it in ways people both enjoy and understand. Now, I'm going to try something I've never done before. Animating the data in real space, with a bit of technical assistance from the crew. So, here we go. First, an axis for health. Life expectancy, from 25 years to 75 years. And down here, an axis for wealth, income per person, $400, $4,000, and $40,000. So down here is poor and sick, and up here is rich and healthy. Now, I'm going to show you the world 200 years ago, in 1810. Here come all the countries. Europe brown, Asia red, Middle East green, Africa south of Sahara blue, and the Americas yellow. And the size of the country bubbles show the size of the population. And in 1810, it was pretty crowded down there, wasn't it? All countries were sick and poor. Life expectancy were below 40 in all countries. And only UK and the Netherlands were slightly better off, but not much. And now, why start the world? The Industrial Revolution makes countries in Europe and elsewhere move away from the rest. But the colonized countries in Asia and Africa, they are stuck down there. And eventually, the Western countries get healthier and healthier. And now we slow down to show the impact of the First World War and the Spanish flu epidemic. What a catastrophe! And now I speed up through the 1920s and the 1930s. And in spite of the Great Depression, Western countries forge on towards greater wealth and health. Japan and some others try to follow, but most countries stay down here. Now, after the tragedies of the Second World War, we stop a bit to look at the world in 1948. 1948 was a great year. The war was over, Sweden topped the medal table at the Winter Olympics, and I was born. But the differences between the countries of the world was wider than ever. United States was in the front, Japan was catching up. Brazil was way behind, Iran was getting a little richer from oil, but still had short lives. And the Asian giants, China, India, Pakistan, Bangladesh, and Indonesia, they were still poor and sick down here. But look what is about to happen. Here we go again. In my lifetime, former colonies gained independence, and then finally they started to get healthier and healthier and healthier. And in the 1970s, then countries in Asia and Latin America started to catch up with the Western countries. They became the emerging economies. Some in Africa follows. Some Africans were stuck in civil war and others hit by HIV. And now we can see the world today in the most up-to-date statistics. Most people today live in the middle, but there are huge differences at the same time between the best of countries and the worst of countries. And there are also huge inequalities within countries. These bubbles show country averages, but I can split them. Take China, I can split it into provinces. There goes Shanghai. It has the same wealth and health as Italy today. And there is the poor inland province Guizhou. It is like Pakistan. And if I split it further, the rural parts are like Ghana in Africa.
And yet, despite the enormous disparities today, we have seen 200 years of remarkable progress. That huge historical gap between the West and the rest is now closing. We have become an entirely new converging world. And I see a clear trend into the future. With aid, trade, green technology and peace, it's fully possible that everyone can make it to the healthy, wealthy corner.
Well, what you just seen in the last few minutes is a story of 200 countries shown over 200 years and beyond. It involved plotting of 120,000 numbers. Pretty neat, huh?
Coming back, I hope you enjoyed the video. Like, it has been showing 120,000 the dots, the data over 200 countries that can be shown very nicely from the visualization, and Tableau made it possible. This is all scatter plot that can be drawn from the Tableau desktop environment. Coming back to my PPT. So from data to wisdom, data are those entities which have not having any meaning. They lack meaning unless and until we convert that data into wisdom. Wisdom means like we have a bricks in the form of data, and we are not converting that, we are not building the information, and we are not communicating something, then it has no meaning. Like the bricks can be converted into house, that only it has some meaning. So we have a process of converting data to information to knowledge and then wisdom. Some examples, like if we have established the instance of any inflation on the consumer price index from last so many years, and understanding how they compare in the how they are compared to be in the preceding years. So this information is made possible through the organization in the form of tables. We have data, we have average, calculated thing, and the end of year statistical data which is assembled together, and then information is conceived finally. So knowledge is also been integrated into there, like this is the process: data, information, and then knowledge. So when the knowledge is conceived, like we have experience of acquiring the knowledge which we are able to understood the things. Like for example, we can have an example of that, the students who are completing the exercises on the topic that the teacher has explained. So exercises need to simulate and challenge, so students will have a problem to solve, so that all the theoretical concepts can be applied on the assignments or the questions or the problems that can be called and fetched from the real life situations. So development of knowledge should be principal aim of any communicating process. If data is transforming into information and it is not knowledge, then it has no use. Then we have wisdom comes into the picture. So wisdom means we have any comprehensive things that has been described from the knowledge. So it is defined in that stage when a person is acquired advanced level of knowledge, like it has been possible to express the final judgment about the data. So study comes into when we interpret something, so it is transmitted and can be argumented as a stories. So we have a data visualization from observation, simulation, and data. Then actually I will quickly give the introductory things about the visualization and then show you the Tableau, and then we will come to AI features because I have very good videos to show you for that. So importance of spatial and spatio-temporal data sciences that has a few complex large data sets like trajectories, maps, remote sensing images, senses and geosocial media. Then this scenario I have captured from Tableau, that it is showing a satellite imagery, weather station measurement like temperature, humidity and wind speed. This is a Tableau environment where we can have columns and rows from the data set, and this is how it has been shown. This is a some mark. There are some marks where you can drag your measure and dimensions. Tableau has a inbuilt feature to detect the value from your data set, that whether it will go into row column or whether it will go to uh, a column, like your data set have rows and columns, so whether it will go to row shelf or it will go to column major shelf. It can be a major or a dimension. So there are two terms that can be automatically detected by the Tableau environment from the row and column of the data set. So it has an inbuilt feature, you just have to drag and drop. So we have monitoring atmospheric changes in the form of space and time, where the spatio-temporal data takes place. It has a space that has across geographic locations, and time is your hour or daily or weekly. So let's see how it's shown here. Then I have these two videos to show you. So let's be finished for the spatial component. The spatial component always show any like what are the cooler regions and what are the polar areas that are hot, equatorial fine, and then rainfall maps that identify heavy predictions with the time when the region is affected by monsoons. So this is the spatial component which is related to the space, and temporal component when the time changes, like the temperature changes over hours, over weekly, monthly, or something hour or time constraints added to the data set. So tracking the movement of hurricanes or storm systems over the particular days is the temporal component of the data. So visualization tool used for spatial and temporal components display is heat map. You can have animated GIS maps, you can have temporal graphs. So by analyzing the various temporal patterns from the data set, enable better preparation for the disaster management people to have a critical role over spatio-temporal analysis in the real world applications. So we have this as well, like the public health monitoring spread of any disease, any food desert, any public safety like crime hotspot, public security, common operational pictures over environment and climate change detection, any land cover if the land is more prone to dryness or more prone to wet. So these can also be displayed with the help of visualization tools. We have a mobile commerce as well, like location based service. So I will go back and play one more good video for you. So to summarize what Tableau desktop can do for us, it has a shapes file, I think. Yeah, this I have for here, like um, this is how like the Tableau this is the Tableau desktop environment, and this is how the dashboard and the layouts been shown over my data set that has these you can control the visibility as well. You can have dashboard story, worksheets, data, server, window, and this is how network analysis can be shown on the Tableau desktop environment like this. You can select any of the data. So this is how you can drag and change the columns and change the spots and can change the settings. So time is short, that's why I have to show more of the things. So I have taken this quick option to show that how we can have these dashboards over here, and we can create these kind of environments from the data set. This is by worksheets from the data sets. See, these all can be combined like that, and we can have an interactive and dynamic dashboards. So importance of data exploration comes under the picture when we have data exploration tasks that are examining data without having any prior understanding what pattern will show me. So while most of the research has been output at the end of certain visualization, but the aspect of these tasks is first to understand the data being presented and then exploring the data. So what is exploration of the data? I have given one example that you can have in the picture that A object is more greater than B and then the C, and the C is the smaller one. This is a very general example of data exploration to pulling the facts out of data. So process of finding the best way to pull out outcome from the data for the specific audience that actually the audience can perceive from their eyes. So this is exploration, comparison from patterns of the data. So by understanding different type of perceptions, data based of the concepts, data exploration pivotal in the form of final visualization due to taking audience into the context, that what audience demand. According to that, we have to proceed, not process, we have to proceed the steps for data visualization towards data exploration. So companies can conduct data exploration via a combination of various automated and manual methods. Like automated tools, just like data visualization, we have Tableau, we have BI, and I will show you one more list that has all visualization capabilities that helps organization and having very interesting observations out of data. So displaying data graphically through scatter plot, density plots and bar charts, we have a very good candidate for the further analysis. So need of visualization with AI tools, I will be starting. So before that, I want to give you a good visual about this one that I have skipped for one. Why data need refinement? Ma'am, is it audible?
Yes, yes.
Uh, okay. Is it audible? The video is?
Yes. No,
Okay.
no. Video is not on. Video is not audible. There's no voice.
Okay. Actually, MS Team needs resharing with audio sound again and again. So I'm sharing it with including sound now. I hope it will be now.
Nassim
Now
Taleb,
audible?
was
Yes.
actually conveying is that, like
Yes,
oil,
yes.
data in its raw form lacks utility. For it to be valuable, it demands refinement and processing. The implication being that this was going to be both the challenge and opportunity for business moving forward. Nassim Taleb, a philosopher and statistician, adds a critical caution to this view. He warns of the risks in over-relying on data without a deep understanding of its limitations, noting that data can deceive us, making us feel secure when we are not. Taleb emphasizes the importance of questioning models based on past events, which often fail due to hidden future variables that differ from past ones, making extrapolation unreliable. In conclusion, data like oil most certainly has value, but it is not a crystal ball that shows you the future as many mistakenly believe. If you like the video,
So data is a new oil. It has no value if it is not been taken at the proper tool, and I'm back for this. So data need refinement with the help of visualization and AI tools. So data is the new oil. As we have more and more oil digged from the various sources, we need to refine it, then only the oil has a value. So this shows that data need refinement before exploration. So we have univariate analysis, bivariate analysis, multivariate and PCA. So univariate analysis of one variable. When we have bivariate analysis, we have two variables. Multivariate, when we have multiple outcome variables. And principal component analysis, little something different from these, when the analysis and conversion possibly between the correlated elements into a smaller number of uncorrelated variables. So this is how principal component analysis work. So univariate analysis, I will give a quick examples, that it will be the salaries of worker in the industry. It can be a univariate data, can be a weight. Then, a survey of classroom can be conducted to analyze what will be the count of number of boys and the girls. This is univariate analysis. The main objective of univariate analysis is always to describe the data in order to find out the patterns. So we can have mean, mode, median, and we can have a frequency distribution table. So this is a quick visual chart I have arranged to show you the types of data. Like numerical data, we call it quantitative. Categorical, we call it qualitative. It has the categories like nominal and ordinal. Nominal data is always connected like that. If you can have a brand, then it is a nominal, like gender, male, female, color, blue, red, green, orange, having a checkbox. Ordinal data is always like if you can rank or order it, like a Likert scale, always, usually, sometimes, rarely, never, 1 to 5 scale. Quantitative data like numerical values, discrete data, if you can count it from 1 to 10. Continuous like length, it is always have a measurement value like weight, temperature. So this is types of data we have. This is the category that needs refinement. It depends what you expect from your data and what your stakeholder expects. On the basis of understanding of data, you explore the data, you refine the data when you record and collect it, and then go for analysis. And then you will choose a right chart for your data. So this is a frequency distribution table for univariate analysis. I have taken a screenshot from SPSS tool. Bar chart is the form of rectangular bars. It has x-axis, y-axis. These are the examples. Histogram is same, but analysis on the basis of data count against the categories. Bin shows number of positions, the range and the interval. This is the difference between bar and histogram. So quantitative and qualitative data, it's shown with the difference. I have given one example already in this, how the quantitative and qualitative data being differentiated. So researcher always often prefer quantitative data over qualitative because it lends itself more easily for the mathematical analysis, because there will be no sense of averaging the hair color or the gender. So it always makes sense to have a quantitative data. We always prefer, if we have something like categorical data, we always try to move it more near to the numbers. So we have bivariate analysis with two variables, like if an ice cream shop keep track of how much ice cream they will sell versus temperature on that day. So ice cream versus temperature, if they have hotter temperature, the sale of ice cream will shoot, and if they have cold, like the weather is cold, the sale of the ice cream will be lower. So multivariate analysis, when we have three or more variables that are categorized under multivariate analysis. Example, that suppose an advertiser wants to compare the popularity of 4 advertisement on the website, and number of clicks will show you that people who are more interested in that particular advertisement, or we can categorize those advertisement that women is more interested in that advertisement or the men. So number of clicks based on the gender value, based on the gender categorization, the person who is proposing that advertiser can come to know that which advertisement is more popular and which product will having a more sale in the coming future. So we have examining this example I have already given, so I will keep multivariate analysis, more examples on healthcare, like dietitian collect data on the patient cholesterol, blood pressure, weight, sugar level, diet. So many variables that are analyzed in multivariate analysis, and they are related to each other, called health. And academician always collect data on the group of students, like demographic, academic performance, to determine how they are related to each other. So importance of data visualization comes when a World Economic Forum produces 2.5 quintillion bytes of everyday data, and 90% of all data has been created in last 2 years. With so much of data, it is very increasingly demanding to the management of data and making sense out of 90% of the data that has been created from various sources. So it is very coming impossible for a single person to wait to a data line by line and see the distinct patterns out of that data. So we need visualization. So choosing the right chart for your initial univariate, bivariate, multivariate data analysis, you make a right decision on the visualizing your data. So whenever you are choosing any category of analysis, we must make a right decision that which visualization tool or what visualization platform we are using to show our data. So effective data visualization should be informative, efficient, appealing. In some cases, it must be interactive and predictive. So these are four categories: informative, efficient, appealing, interactive, and the predictive. Prediction is optional. If your stakeholder or the client needs prediction over data, you can go for that. So pillars of data visualization are four: distribution, relationship, composition, and comparison. I will show you with the help of pictures and example. This is the very old picture from the import and export that has been shown in the Scotland, UK, how they were using it on the paper. This is a chart suggestion. I have taken combine on one picture so that I can quickly skip to the AI part. So these are some of the chart suggestion, starter guideline if you are new to the visualization tools. These are comparisons. If you want to do comparisons, you can opt for these charts. If you want to have distribution, you can have these charts. If you want to show composition, you can opt these charts. And if you want to show relationship between two variables, three variables, you can go for these charts. So this is how you can take it as a starter guide. A connection between two things based on co-occurrence is a correlation, like there is a correlation between drug abuse and crime. So correlation is always a strong relation between them. So between when there is a two variables that are strongly correlated with each other, like if the drug abuse increasing, the crime will increase. Age and weight have correlation, but there is no correlation between culture and hobbies. So hobby has no relation with the culture and culture has no relation with the hobbies. So they are two independent things. So we have these all examples: distribution related to single, relationship between two variable always, composition having single or multiple variables, comparison can be between two different categories or individuals. So this is distribution, a flip of coin. Sometimes you will get head, sometimes you will get tail. So this is a distribution. This can be shown like this between student height distribution in class. Dispersion is another category. You can disperse and spread with respect to the central tendency. We can have median, minimum, maximum, outliers. You can have box plot with this. Uh, Relationship, like tree grow taller as they got older in early years. There is a relationship between these two variables. Height and age has a relationship. More cars will increase the pollution index. Car count and PI is the relationship. More cars uh, will increase the pollution. Obviously, screen time will decrease your vision. Eyesight has a relation. So I have created few functions out of that. Height is equal to function of age. Screen time is a function of vision. Respectively, car have a function of pollution index, and price has a function of number of bedroom, bathroom, location, area for the cost of house. Comparison, multiple variables, one data set, multiple categories in single variable, like occupation data set. If we can compare their salaries between doctor, lawyer, and professor. Composition, yellow, like if you want to show the composition, one second. So you can show like that in the form of pie charts. So these are relationship and connection between the data points. You can use all these charts. I have mentioned the name as well, and these all charts are available in the Tableau. You can choose. These are the heat maps that can showcase from warm to cool color spectrum, like darker to the light color tone, show you the maximum range of the value and the minimum range. I have shown already in the previous examples. This is how. This is one example. The number of page visitors over website, like the darker is showing the maximum readers have read this portion of the web page. The lighter the color, this one has the reader have less eyes on this particular part of page. So this is how our website or it is helping a user interface designer to show that which content got more popularity and which content of the website has less popularity. This is how we can use heat maps. So these are all heat maps I have put into one picture. All are available in Tableau. You can see and have and gain knowledge about which heat chart can use for what purpose. This is one I have generated indicating the rainfall pattern from 1998 to 2018. One data set has been taken. You can see the precipitation less than 0.1 have these month and greater than 2.0 in these months. The darker one means the July having maximum rain, and the lighter one has less rain. So this is how you can use clustered heat map. Some have negative correlation also can be shown, like increase in variable height will decrease in temperature. As you go more in mountains, the temperature will be decreased. The older a man get, the less the hair he has, negative correlation. So these are some example, same negative correlation. This is how our heat map is shown to show the sepal width, petal width in a flower spaces data set. Converted a chart into heat map to show the new revenue generated. The Excel sheet I have converted into heat map. You can have an add-on on the Excel. You can convert your Excel sheet into heat map with basic features in Excel, MS Excel as well. This is the option you can convert. You can have a scroll bar over the heat chart. This is a geographic heat map, a Microsoft app available that you can convert your geographical data into a geographical heat map with the help of these maps. These are Marimekko charts. Data is sorted. You get and gather data like this, then you sort it and then you arrange it and then you present visually. Here the visualization comes and tools we opt. And then it is explained with the story. So dashboards and spreadsheets only tell what is happening, but why, like they do not tell you why we are doing this. So we have tools for this, adopting a data storing culture in the companies nowadays. So what is the data story? I will show you some good examples. Like this is the data story, 19,456 minutes Spotify you have listened through music apps. This is the story they present to their clients. This is a Slack, like some of emails. Slack is a communication tool replacing the traditional outdated train of emails. This is Uber, how much you used in your city. This is a story, like how many rides, how many miles you travel, your rating on Uber. So this is how the story has been generated from dashboards and from the data collected. So this is understanding the context of data, then effective visuals, then clutter, then focusing the attention, and then telling a story. So now AI tools for data visualization. So Tableau is a business intelligence software like that has AI driven data visualization capabilities and has a very user friendly interface and drag and drop functionality. And there are other as well, Cizen, Luzmo and Pricoto chart. I have only been able to get the Tableau AI features and BI AI features. So I will give you a quick look how we can see Tableau. We can have a Tableau installed, Tableau desktop installed like this. Then what Tableau can do for you, I will give you a quick look. 1 second, so that you can see in a very quick summary that what Tableau can do for us. I'm sharing with the sound.
Tableau and
Ma'am, is it audible with the sound? Ma'am?
Yes. Yes.
Is it with the sound? Okay.
empowers everyone
Yes.
to see and understand their data. It's business intelligence for your entire organization. Explore and analyze data in seconds. Just drag and drop to discover trends and outliers. Or use natural language to go from question to answer in an instant. Connect to the data you care about, whether it's a spreadsheet, database, or big data. Access data warehouses or cloud data. Tableau Prep helps you quickly and confidently transform and shape your data for analysis. Easily combine data from multiple sources. See all your data at a glance with Prep Builder's visual and direct interface. Smart grouping algorithms make it easy to reorganize your data. Then, publish and schedule your flows with Prep Conductor. Or open the output directly in Tableau Desktop for analysis, where you can ask questions, change your perspective, and reveal deeper meaning. Transform your data into powerful interactive dashboards. Securely share your data and dashboards with Tableau Online or Tableau Server, so everyone in your organization can ask and answer their own questions, right from a browser, tablet, or phone. Whether you want a fully hosted solution like Tableau Online, or to manage your own Tableau server on premises or in the cloud, the choice is yours. Everyone in your organization can access data and dashboards to explore and find their own insights in a trusted and secure environment. Tableau's management tools give you control over everything, from user permissions to data source connectivity, and the visibility you need to support your deployment. Tableau naturally fits within the fabric of your business, so you can easily scale from small teams to full organizations with thousands of users. Tableau. See and understand your data.
So this was the quick look what Tableau can do for us, and I will show you one my Tableau desktop environment, how this video is shown to you. So these are the Tableau desktop server environment you can choose from. These are the products. This is how visuals are shown in the Tableau. Tableau Public, Tableau Reader, Online, Desktop Reader, and Cloud. Tableau Cloud will give you the features of AI thing. So what is AI in Tableau? So AI in Tableau is that brings a trusted instant generative AI capabilities to the entire platform. It has been added as a generative AI layer as an instant generative AI capability with the Tableau. So we have Tableau Cloud, which give you two features for enabling AI, Tableau Plus and Tableau Agent. So I will show you each of them one by one. So this is how connecting to the data in Tableau, we can convert the data into visual formats like this, and we have these products on the Tableau desktop. Then this is how I have captured one sample superstore data set, two column and rows. This is how the region is being generated in the Tableau worksheet. These are the sheets and this is the data source. These are the tables from the data set. Then Tableau environment is like this, how you can have a sample superstore data set. It has one coffee chain data set as well as three more to work upon. Here you can drag your sheets. Here you can have a canvas view. Here you can have a grid view, which is all been shown in the video, but I am giving a captured snapshots from my Tableau environment. So grid view is always show you the metadata, data about the data. It has a data preview, quick checks on the aggregation calculations and data types that has been used in the data set, as well as it will help you in the adjustments of visual elements that you after that you can have column and rows, like if you are building a sales report, you can have salesperson, region, month, sale amount in the column shelf, and like corresponding values for each salesperson, region and month will be in the row shelf. This is how grid view will I have dragged sample superstore data set in the Tableau environment, and I am showing it in the preview grid, like order, people and return. These are the main important sheets under the data set. So this is how you can see the order date of order table, shipping date, shipping mode and customer ID. Then you have a manage metadata tab in the metadata grid. This is manage metadata tab, which you can see the field name, the table these fields belong to, and the requested field names. Then you can have a worksheet view here for the data field and the data sources. This is sheet 1. You can rename your sheet accordingly, and when you will click on any of the data table and you can drag them over column and rows, you can create a worksheet view here. So this is data, text and date. These all are uh, always here. The majors are always number. Sets are the subset of something on some particular condition on the fields. This is how you can organize your data set fields. This is how analytics, when you will switch from data tab to analytics tab, it will allow you to add trends, forecast and plot in your view, worksheet view. This is how we can do. I will show you next. This is, it will allow, like Tableau has an inbuilt feature to determine about your data type. Like if you only have to connect your Tableau environment with your data set, like it is in CSV, Excel or any data set, it will automatically determine and know whether it is a string or a number. So it has a support to detect any kind of values in the data set, like text, numerical, geographical values, date value, date and time or Boolean values. It will automatically detect that. You don't have to do any conversion. So note the color when field is added to the shelf, like determine the behavior of the field when it is placed on the shelf. It is continuous. See, when the chart is generated in blue, means you are adding a continuous data. And when the shelf color become green, this means the chart will show you the continuous data. And when the field added to the shelf blue, this means this is the discrete data. Like this. So dimensions are always there. Field can be dimension or measure, anything. Like I have added a region field to the column. Then measures like quantity and profit, like added like this. So we have data source page, left plane, like double click on the order table. When you will click that, the order table will be displayed like this. Then you can create a view like this, sales view. You can have a mark cards where you can place your measures. And then you can create sheets like this from the text tables. Like this, when you will click on show me, and when you can when you are place your column and row from the data set, you can create a chart like this. And Tableau will allow you to connect 50 plus data sources from a file, from a server. Like you have a support of these big data support, relational data, and these MySQL, SQL Server, Tableau Server, Amazon, Oracle. You can connect to these data sources, and these are the file support. These files, MS Access, text, Excel, you can connect your Tableau environment with these files. And you can have a connection of more than one table with the help of joins. It will automatically detect left join and join, like inner join, left join, multiple join, and combine multiple tables. You just have to open two table like sample superstore dataset and coffee chain. You will get to know what tables are included in both of the data sets. You can drag them and you can create joins like this. You just have to click on join. It will suggest you inner join, outer or right join, these three. And this fuller outer join is not available. It is only available when you have a data source connection with relational database management system. Inner join is placed like this. This is how you can add different color to each category. You can customize your charts. When a view is ready, you can put union as well. Like this, you can edit unions when you have to combine, sum up all the tables. You can give your custom SQL option. You will click new custom SQL. If you are ready with your SQL query, you can have like this. You can create your own query, but for that you have to connect to MySQL. Then you can create a view. You can rename your views here, like worksheet view, sales by city, sales by region, sales by country. This is how I have generated one worksheet view with my data, sum of number of regions and the city wise. Then this is one, I have created one query, and by executing that query, uh, I have created this view by dragging and dropping the city on the mark card, and then column and shelf from the data set. Then I have added column to row and column to shell and created a view from the data set. Then you can create dashboards. Like dashboard is meant for when you have multiple worksheets in your data set, you can combine those worksheets in a single view, in a single layout, which is called dashboard in Tableau. So dashboard is always a collection of one or more sheet at a single place, and it is a consolidated display of many worksheets that are created, an efficient way to extract actionable insight. So when you combine your worksheet 1, worksheet 2, and it is added to the dashboard, and when you will have an update on worksheet 1, it will automatically update your dashboard as well. So in this way you can create your dynamic dashboards, and you can always save it. So I have given one example for this. Like I have taken one worksheet here, and second by subcategory, sales by subcategory. And then I have created one more sheet and added, drag the year order to the column shelf. And then I have created this sheet to have maximum and minimum values out of sale. And I have 3 sheets added like this, and now these 3 sheets will be, I don't want to switch from one sheet to another, so I will create a dashboard so that I can have a single consolidated view of these 3 sheets at one view. So this is how I have done. This is how I can create a dashboard. I have marked it with a marker. So these 3 sheets, where when I will hover my mouse here, it will show you like this. When I will hover my mouse on subcategory, it will show you the view. But you can select these sheets what you want on your dashboard. So you can customize your dashboards like this, automatic. Uh, there are a few options like tiled, floating dashboards, what you want. When you will do it and practice, then you will feel the difference between the floating and the tiled dashboards. So this is one dashboard, one created for these 3 sheets. You can name your dashboard any meaningful name you can give. So if you want to opt show dashboard title, so I have opted it, and then I will have a floating dashboard like this. So my 3 sheets are here and on a single view, so I can represent this to my client or any end user to have a sales analysis dashboard for sales by category and region. I can show sales by subcategory. I can show monthly sales of minimum sale and the maximum one. So I can have a consolidated view from the multiple worksheets belonging to single data set, which is called sample superstore data set. Then I can apply certain filters of interactivity. This is I can have furniture, like I have taken one store data set which has a category of furniture like this, category furniture, office supplies and technology supplies, region wise sales I have shown, and then I have shown sales by subcategory. You can see the other sheet is showing on the dashboard, the same dashboard showing the single category of furniture like this, and this is the monthly sales. So you can try these all filters on your dashboards. I have marked them. So we can have actions over dashboard like highlight, URL and filter actions. This is the filter action. I have already shown that you can put some filters, and then you can choose and source and target that where it should be displayed. This is how to launch actions. Select all fields, selected task, monthly sale category, and then this is how you can filter the target dashboard. Like you can combine dashboard 1 and 2, and you can filter where you want to put that sheet or transfer to the source dashboard to the target dashboards. So you can combine 2 dashboard as well, and you can add the filter section. This is the highlight one. You can highlight like this, hover, select menu, shipping trends you can see. Then you can add interactivity to the dashboard by having URL actions. Like you can have a web link embedded on your dashboard like this. You can give your URL. Like I have tried it with Wikipedia one, wikipedia.org. I have tried, it was working fine. And you can click run as. So it will show you the link, test link. You can click and it will work for testing. You can put the final one on your dashboard like this. See, I have added a hyperlink here, shown, added here. From here, when I have tested the link, I have the hyperlink is shown like this in my office supply dashboard. This is how you can create layout for devices. You can choose the device type. By default, it will show you like this. You can have a device preview as well. You have a support of device independence over mobile and tablet. You can create view for both and you can test them. This is how Tableau stories are being. You can show your worksheets with the Tableau stories. Narrative view to the audience can be shown. It's very nice presentation tools used for collaborative analytics. So you can create stories like this. This is a story point. You can show them like this. How you can create a new story. I have marked it for you like this. You can keep the titles on and off for your stories. You can format them like this. And this is how the stories can be created. Like I have created one sales analysis story. These are my story points. You can switch between your story points. These are the captions you can give. You can drag the dashboards, arrange story points. You can try publishing them with your team over Tableau Public or Tableau Server or Tableau Online, but you need your credentials to do that, to save that. And then you can connect with the Excel like this to existing, like you can, existing sheets also can be connected to the stories. And then you can have this like this. I have created one story. You can have a calculated fields. These are the various Tableau charts that are available. Major names, major values, bar charts like this. You can remove the majors like that over mark cards. This is I have shown, and I'm just again having a quick review with you. So analyzing multiple measurements like profit, quantity, sales, you can have it. This is I have dragged the postal code, a major column, drag major name in color and mark and change the color like this, and created three story points over one dashboard. Can create all of them. Geo map visuals you can show, like you can have a state over the dashboards, like geo visuals in Tableau. You can create area charts like this. You can have bar charts like this. So I have taken some good examples and drag and produce charts, box plots like this, bullet graphs. You can Gantt chart like this, line charts. You can have geo visuals like this, sales map over the geographical region over the map. You can explore these options as well to show the numbers. These are motion charts. So Tableau being used by all these organizations at Dubai airports, at these good companies selling the cars, key bank employers, 10,000 employees with actionable insights in Tableau. Some food markets, they're also using Tableaus. So Tableau for teaching also, you can get Tableau for free with your credential, academic credentials, and you can get Tableau for your class. So Tableau products having AI enabled features, you can have like this. When you will click on tableau.org, you can have artificial intelligence feature. When you will click on that, you will get two products, Tableau Pulse and Tableau Agent. So getting from data preparation to the visualization very faster with a trusted advisor right into the flow of work being embedded by AI features. So it will help us to make better decision, flexible and AI powered analytics platform. So AI in Tableau with accelerating the data culture with AI powered insight. Previously the manual methods I have shown you because there is a need of human knowledge and wisdom before we use AI. So but the AI feature embedded into Tableau environment will give you a more AI enabled insights and decision making. So AI in Tableau will help you to to perform data analysis and simplify the insights and more quicker way, because it has a trusted generative AI capability and a layer added to it on the Tableau platform. It accelerates the time to value, reduces the repetitive task we do for the data analyst or the business analyst. So as the AI is built as an instant trust layer, it allows the administrator to enable the trusted and open AI powered experiences without compromising any data security on the data. So AI in Tableau has increased an additional power, being smart, personalized and contextualized insight in the flow of data visualization. So it will help easy to use self-service analytics, governance, security, compliance built into the Tableau, a semantic layer. So it has a supercharged analyst getting from data preparation to the visualization very fast, trusted advisor that are right in the flow of work. Excuse me for a second. So this is how engaging, understanding the act, having generating AI and natural language, flow automation, browser-based support, desktop application, mobile application, collaboration management with an advanced analytical engine, AI and ML with the Einstein trust layer. with API developer ecosystem, managing the trusted data, connecting to all the data like cloud data, databases, applications, files, and flexible deployment over Tableau Cloud, which is software as a service, and Salesforce Hyperforce, public cloud servers, and the open performance servers. So this is a built-in architecture that has been added as a trusted layer in the AI features of Tableau. So Tableau Pulse and Tableau Agent are two AI-enabled products that has been added. So 87% of analytics and IT leaders says that advances in AI make data management a very high priority nowadays. 94% of the business leaders feel that their organization need more value out of the data. 92% of the analysts and the IT leaders say that need for trustworthy data is higher than ever nowadays. So these are two products. So leaders are redefining the data governance to prime their data for preparing them to the age of AI. So data governance is a key step to ensure the data quality, trust and privacy. But the companies are still struggling with securing and harnessing the massive volume of data. So leveraging all the productivity gains of generative AI without compromising on any security and privacy, we have Einstein trust layer that enable the AI features in the Tableau, which has a built-in trust layer. This trust layer protect the privacy and safety of our data so that we can unleash the power of AI without compromising any security on the data. So this is, I have shown you a Tableau environment, but this AI instant discovery has been added at the Tableau environment. You can feel it like here. And then intuitive data experience for everyone, making analysis very fast. This is a Tableau Pulse feature. Like Tableau AI has two things, Tableau Plus and Tableau Agent. So Tableau Pulse has these easy to understanding automated generated narratives to the dashboard using natural language, exploring critical business questions and personalizing metrics using Tableau Pulse. Then we have confidence and trust in our data, like ensuring that visibility, a single sign-on agreement and identity provider to each user, monitoring the usage on one environment that efficiently stay with the compliance, enjoying up-to-date infrastructure as a service, security certification standards like ISO for Tableau Cloud Enterprise, Tableau Pulse, Tableau Server Enterprises, and uh, like it can give you a single identity use. There is a feature, secure feature that monitor the usage, who is using what over Tableau, easily scalable environment, up and flexible platforms, reusable models, configuring them, then mission critical analysis, very easy to build up and maintaining the control of advanced management capabilities like this. Uh, then Tableau agent accelerate the data-driven decision making, trusted AI, collaborating with conversational AI assistant to breeze the data preparation, creating visual very easily. So I will give a view on that now. Ma'am, you have to confirm whether it is with sound now. We'll give a quick, that how AI will help inside tab. Sharing with sound now.
Tableau agent is
Ma'am, is it audible?
Yes.
Okay.
your trusted AI assistant for analytics in every step of your data journey. You can kickstart data exploration with suggested questions, or you can ask your own question in natural language. Tableau agent will automatically apply analytics best practices and recommended chart types to your prompts. And with Tableau agent, you're in the driver's seat, so you can readily go between working with Tableau agent, making modifications on your own with traditional drag and drop, and back to collaborating with your analytics agent seamlessly. It can even help you create calculations, turning intent into syntax in seconds, so you can dive even deeper into the trends in your data. Tableau agent helps with more than just exploration and visualization. You can also accelerate data preparation with the ability to create calculations in Tableau Prep and generate descriptions to enrich your metadata with a single click in Tableau Catalog. Tableau Agent is your trusted AI assistant to accelerate your data journey.
So this is how Tableau Agent, an AI feature that has been added to the Tableau and can have assist a quick thing over the data you can have, and Tableau Pearls as well. So it will also show you how people get engaged with the diversity of the data, and with a one quick view, an AI enabled feature will help you with that. So this is a Power BI desktop environment. I will show you quickly how it can be used with AI feature. These are the data sources that has been added with the PI, like it can be connected with the Power BI. You can get data like this. You can have a common data sources like this. You can connect with databases support. All these are here. Like when you will click, you will get a overview that how databases can be imported like this. It has a support of all these databases. This is how you can log in. These are some of the advanced options over Power BI. How you can create a data model in Power BI by connecting like this. Then Power BI desktop views has report view, data view, and the model view. You can have query editor like this. You can customize your own queries. You can write a blank query as well. You can have sample superstore dataset. I have taken sample superstore dataset and I have captured the screenshots for you, like order table, return table, people table. You can have like this. This is the loading of dataset. And then you can create a view, table view of your loaded data. You can give a name from the field pane, like manage the relationship between. It will give you auto detecting relationship between your table like this. You can create a relationship view like that with two sheets with customer name, production ID, production name. You can create dashboards like this in Power BI desktop. This is my screen. I have created one dashboard. You can add labels, use formatting tabs. You can have sales by state. You can have all visuals on the dashboard like this. I have published them over my workspace. You can see this is my workspace and I have a mobile view as well like this of my Power BI dashboards. You can have BI service and dashboard like this. This is my space. I have created one account on Power BI desktop and app.powerbi.com. You can create your own workspace over cloud. You can see your dashboard reports like this. My first DB PBI, my FDB PBI, I have created with the data set and created one report. You can also create your own workspaces here. Then you can create like this over page 1, 2, and 3 over the workspace in Power BI. These you can pin visuals like this, pin to dashboards. You can have a mobile layout like this. You can create mobile layout, or you can quickly go to dashboards. This is a mobile layout. You can check your dashboards like this. I have created, and you can have a view like this. So how using AI insights in Power BI desktop, you can have a support of text analytics and vision in Power BI. You can apply different algorithms over that, and you can have sentiment analysis, key phrase extraction, language detection, and image tagging. These are the 4 features that been available on AI insights in Power BI desktop. This is how it can detect any language with ISO identifiers. Text analytics recognize up to 120 languages on Power BI desktop. You can extract the key phrases. It has a language ISO codes. You can score sentiments from language ISO code. It has a pre-trained models with sentiment associations. Tag images, you can have give any 2000 recognizable objects and it will give you the categories and tag the images automatically with AI feature in Power BI desktop. This is how text analytics is done in Power BI. It can detect the language. So Google, Facebook, Amazon, Apple, Twitter, Netflix all have better questions of their data and make better decisions out of these data visualization. So these are the tools for big data visualization. Tableau has also support big data visualization and Power BI as well. So deep data visualization also you can do. So data is the new oil. No, I will say data is the new soil. So machine learning data visualization examples can best suited out of these tools. So as we need the most valuable resource is no longer oil nowadays, but it is the data that is the most valuable resource nowadays. So we have to dig more oil, refine it, and we also need data to be refined to get more values out of it. But data is the new soil. because for me it feels like fertile creative medium. Over the years it has an online value, and we have laid down a huge amount of information out of that data, so we irrigate it with more network and more connectivity. So data is new oil as well as new soil. So I will conclude my remarks here and say my thanks to the organizers to give me so much time to speak on this platform and presenting my views and somehow my knowledge if it is helpful for the audience. So thank you so much, Dr. KK Singh sir and Seema ma'am. Over to you.
Thank you, Dr. Madhulika, for this informative session on W. This was a really interesting session. Thanks for
Thank you, ma'am.
joining.
Thank you. Okay, ma'am. Like, I'm free to leave.
Yes, yes, Dr. Madhulika, you can leave.
Okay. Thank you so much, audience, for listening me. Thank you so much.
Dear participant, just wait for, we are just starting the next session also.